is by far the most common. And the key concepts of a relational database is that you have data organized into tables or relations, because the tables are related to each other by certain rules.
So that seems it will be similar as I'm storing the data in a program like Excel, where you have a lot of columns and rows.
It's just about the same structure as the Excel, but here you have the combination of one or many tables. So,
and of course, in Excel there is no database management system.
No.
So you can of course not classify that as a database program.
No. And also, the tables will contain rows. That's one of the definitions. It's easier to think about the database tables as normal Excel tables, maybe. And all the rows in a table have the same columns. That is just about the same as an Excel form.
And if we talk in GIS vocabulary, we would say that we often call these columns attributes. And
columns or attributes, yeah.
Yeah, and the rows will be one object. Yes.
That's equivalent to one object. And also each column has its own data type, which could be integer, decimal, date, or whatever.
Yeah.
Those are the key concepts of a relational database. So
we could see one down here.
Here's a simple example of a database table.
So that it has 3 rows and 3 columns.
First we have the ID column, which is just an ID number. We have a name, which is a text format, and we have date of birth, which is a date format. And one row in this table is called a record.
Yeah, and that would be similar, as we said, like an object in a GIS system.
Yeah. A little bit more about the database integrity. The content of a database is governed by some rules. To make sure that these rules are followed, it's called to keep the database integrity.
Integrity is, for me, is quite difficult word. I don't know. Is that how would we characterize the word integrity? Is that to keep the? I mean, the you end with is called to keep the database integrity, but you could say
to keep the database well structured, you might say, according to the rules that you have set up.
Okay, so it's linked to the word inconsistence, perhaps that we talked about earlier also.
Yeah. If you have inconsistency in a database, you don't have integrity, you could say.
Okay.
So there are a number of ways to keep the integrity, and here's just 3 examples. You might set up that numeric columns will not accept alphabetic values. So, like for instance, if you want to store the age of a person, you cannot store a value that is made up of letters. You only can store numbers. A record in one table must have a corresponding record in another table. That's where you have the relations between different tables.
So that means that you could have some more or less communication between the tables. They can be linked, and you have to be sure that these linkage are maintained during, for example, an update process of the database.
Exactly. You could, for instance, if you have one table that has students, and another table has a list of courses, and maybe you set up a rule: if no student is taking one course, it should it should not exist in the course table.
Yeah.
That could be one rule that you have set up in the database. So if for one reason or another, if you delete one student, the only student that was taking this course, it should also be deleted in the other table.
Yeah. You should all be aware of that Roger has created a database of all of you.
Yeah.
So all Luma students are in a database where it says which courses you have done and so forth. And this is just one example of how you could use a database.
You can also set up that a column will only accept values in a specified interval. As I mentioned earlier, if you want to store, for instance, months, which should be from 1 to 12.
Yep.
So you set up a rule, it can only be numbers between 1 and 12. So how do you keep the relations between the tables? You use referential integrity by keys. First you have the primary key. A table should always have a primary key, which is a way to make sure that you can always find a unique row or record in that table.
The reason must be that it's not allowed to have two rows that are identical in a relational table.
So the primary key can be built up of one or more columns. That is, these columns has combined or separate a way to express themselves as unique.
Okay. So suitable primary keys are